Hi guys. So today we're going to look at the last possible triangle setup, and that is something called the ambiguous case. So the reason we call it the ambiguous case is because we have actually a couple different possibilities that what can happen. It's a little bit unclear. So what we have to look out for, and this is the case that we just really have to use some caution with. We need to kind of be looking out for it. When we know two sides and the angle is not in between, what that looks like is side-side angle. So you may remember that from geometry. Side-side angle we did not use to prove congruency because if you spelled it backwards, it spelled a bad word. The reason we can't use it to prove congruency is kind of what we're going to look at today. Depending on the setup of your angles, it's actually possible to get more than one triangle with the given information. So when you have side-side angle, you'll know two sides in an angle, but the angle is not in between. So what I mean by that, let's say I know this and this. Okay, if I know this angle right here, that's side angle side. That's okay. The other thing you'll know is when you see it written out, all three letters will be different. Okay, but if I don't know that angle, if instead I know either this angle or this angle, that would be a case of side-side angle. So side-side angle is going to be our ambiguous case. All right, so what we're going to do is we are going to use the law of sines. Okay, but we need to be careful because this is the ambiguous case. So what could happen is actually one of three things. It's possible that we could have zero solutions, we could have one solution, or we could have two solutions. So all of those things are possible, and we'll look at all those happen. So what we're going to do to solve is we will use the law of sines. But what we really need to look out for, okay, anytime we set up law of sines, if we have to use sine inverse, then that's when we really need to be careful. Okay, so it's using sine inverse where we're going to have to look out. If we use sine inverse, we have to check for a second angle. So sine inverse is going to give us one answer on the calculator, but there actually are two answers. The other answer could be 180 minus whatever we get, and that could be our second possible answer. So all I have to say, let's go ahead and look at an example. So we're going to draw our triangle. Angle A is 42, side A is 22, and side B is 12. So this is side-side angle. Because again, I don't know the angle in between the two sides. All three letters are not different. I have two of the same letters. So what I'm going to do is I'm going to set up law of sines. All right, so sine 42 over 22 is equal to sine B over 12. So we'll cross multiply. Sorry guys, there's going to be another one in 5 minutes. I'll try and pause it before if I remember. It's 22 times sine B. This is the problem with having third period off. All right, and then our goal here again, we're going to cross multiply and divide. We're going to get sine B by itself. So I'm going to divide both sides by 22. So I get that sine B is equal to, and I need to grab my calculator. Make sure your calculator is in degrees. So 12 sine 42 divided by 22. I've got 0.36498. And that's what sine B is. Okay, so remember, we're looking for an angle. To use an angle, we're going to do sine inverse. So I'm going to do shift sine. And then if you use the previous answer, you'll get the most exact. I'm going to go ahead and just round this to the nearest whole number. And I get that angle B is equal to 21 degrees. Well, now, like I said, if we use sine inverse, there actually are two possible answers here. And we'll get into a lot more about the reason for this when we do some inverses in a future unit. But what you also can think about is think about your triangle because they add up to 180. So our second answer that's possible, we're going to do 180 minus 21 degrees to find our second possible answer. So angle B could be 21 or angle B could be 159. In this particular case, though, if angle B was 159, if I went and put that back into my triangle, and if I had a 159 degree angle and a 42 degree angle, I need to think, is that possible? Well, no, it's not possible because 159 plus the 42 that's already on there, that's more than 180. So that doesn't exist. So even though this is that ambiguous case, there actually still is only one possible answer here. So let's go ahead and finish solving this triangle. So now we know that angle B is 21. So now I can subtract from 180 to get angle C. So I can do 180 minus 21 minus 42, and I get that angle C is 117. And then I can do law of sines to find side C. And I'm going to use the original just so it's a little bit more exact. So sine 42 times C, so 22 times sine 117, divide by sine 42. Plug all that in your calculator, so 22 times sine 117 divided by sine 42, and I get 29.3 for side C. And again, we can double check, make sure our answers make sense. Okay, our biggest side is side C, 29. It's across from the biggest angle. That makes sense. All right, so let's look at another one. So this gives me, again, one angle and two sides. So one angle and two sides is either side angle side in law of cosines, or it's going to be side side angle in the ambiguous case. So let's see what we got. Angle X is 85, side X is 15, side Y is 25. Well, this is side side angle. This is the ambiguous case. So we'll do law of sines. So sine 85 divided by 15 is sine Y over 25. So we'll cross multiply. So I get that sine Y is equal to 25 times the sine of 85 degrees divided by 15, which is 1.66. So in order to find an angle, we use inverse. But if you do sine inverse on this, you're probably going to get an error. And that is okay. You're actually supposed to get an error. It's not possible for sine to be greater than 1, because sine is the ratio of opposite over hypotenuse. Your opposite can't be bigger than your hypotenuse. So this is not possible. So what that means is this triangle actually is not possible. There is no solution. There is no triangle. So like we said, there's a possibility when we do side-side angle to get no triangles. There's a possibility to just get one triangle, or there's a possibility of two triangles. So this is our last example, so you can probably take a guess on what's going to happen here. But let's go ahead and draw it out. So angle A is 20, side A is 12, side B is 31. So again, this is side-side angle. I know two sides, but I do not know the angle in between. So we'll set up law of sines. Sine 20 over 12 equals sine B over 31. Cross multiply and divide. So sine B is equal to 31 times sine 20 divided by 12. So sine B is 0.88355. So again, in order to find the angle, then we have to do inverse. So I'm going to do shift sine, so sine inverse, and I get that angle B is 62 degrees. Now again, this is where you have to be careful. Whenever we do sine inverse, we have to check for our second answer. Our second answer is 180 minus 62. So whatever I got, I'm going to do 180 minus that, and I'm going to do 118. The reason for that, again, if you just plug in your calculator sine of 62, you're going to get that decimal we just had. But if you also type in sine of 118, you're going to get that same answer. Okay, so those are my two possible answers for angle B. All right, so angle B could be 62, or angle B could be 118. So since I have two possible answers, I'm going to go ahead and draw a second triangle to make this a little bit easier. And I'll keep this second triangle a different color. So now I have all the same original given information, but angle B is 118. So now let's go back to my purple triangle. Okay, the original angle B I found was 62. So let's finish solving this triangle. Let's find angle C. Well, angle C, I'll do 180 minus 20 minus 62 to get 98. And now we can find side C by using the law of sines. So sine 98 over C equals sine 62 over, actually let me use the original so it's not rounded. I'll do sine 20. It's okay if you did 62, I just think it's a little bit, it'll be a little bit more exact if you use the original. And then we'll divide. So I've got 12 sine 98 divided by sine 20. So side C is 34.7. All right, so those are three of my possible answers. But again, there's a second triangle. So angle C and side C have two other possibilities. So let's go back to our blue triangle. If angle B was 118, well then angle C is going to be different. 180 minus 118 minus 20 is 42. So angle C also could be 42 degrees. Now let's find side C. Again, we'll set up law signs. So I'll do sine 42 over C equals sine 20 over 12. Cross multiply and divide. So divide by sine 20. So 12 sine 42 divided by sine 20. And side C, if angle C is 42, then side C is 23.5. And that makes sense because if angle C were bigger, the side would be bigger. All right, so that is the ambiguous case for the law of sines. So again, if you're given side-side angle, you need to be careful because there could be no solution or there could be two solutions. What you do is anytime you use sine inverse, you're going to get an answer for an angle. But your second possible angle is 180 minus whatever the calculator gives you. And we got to check to see if that second angle is actually going to work.